Hello everyone. In this video, I will answer the questions which were asked in the previous video. In the previous video, I asked that a rubber band changes its shape when an external force is applied to it, so whether it is solid or not. Rubber band changes its shape when an external force, external pressure is applied to it, but when the pressure is removed, it regains its shape. Means the overall change in the shape of the rubber is zero. Therefore, it is a solid. The second question, that sugar and salt, when kept in different jars, they take the shape of the jar. Are they solids? The answer to this question is that when sugar and salt are kept in different jars, the crystals of sugar and salt maintain the shape. There is no change in the shape of crystals of sugar and salt. Therefore, sugar and salt both are solid. The third question was, sponge are easily compressible, or sponge change its shape when it is compressed. So is it a solid? The answer is that sponge contain minute pores in them. Those minute pores have air filled in them. When we compress the sponge, we are expelling out the air. That means the sponge does not change the shape, it just expelled out the air. When we remove the pressure, the sponge maintains its original shape. Therefore, sponge is a solid. Moving to the new topic, that is the liquid state. The major characteristics of liquid state is that liquid particles are loosely held as comparative to solid. Solids have the particles closely packed to each other in this manner. Comparing both the diagram, we can say that the particles of liquid have space between them, that is intermolecular space. And in the case of solid, the intermolecular space is negligible. Or we can say that the particles in liquid are loosely held, therefore the intermolecular force of attraction is less in liquid as comparative to solid. So we can say that the intermolecular force of attraction in liquid is less, and the intermolecular space in liquid is higher than solid. Second property, the liquid does not have any fixed shape, but the volume of the liquid is always fixed. Taking an example, if we take 1 liter water in a bottle and we transfer that 1 liter water from the bottle to the bucket, what will happen? The capacity of water will remain same, 1 liter in the water bottle, and if we transfer the 1 liter of water to the bucket, the water volume will remain same, 1 liter in water bottle and 1 liter in the bucket. But the shape of the water will change from the shape of water bottle to that of bucket. Thus we can say that liquids have a fixed volume, liquid have a definite volume, but the shape is not fixed. Then we can say that the density of liquid is less than solid. I explained you about the density, that density is equals to mass divided by volume. Mass divided by volume means if per unit volume, if the mass is high, density will be high, and in per unit volume, if the mass is less, density will be less. Mass will be high when the number of particles will be more. So In liquid state, the number of particles in per unit area is less, therefore, the density of the liquid is less than solid. The next point is liquids have the ability to flow, and the substances which have the ability to flow are called as fluid. The matter which have the ability to flow is called as fluid, and the property to flow is called as fluidity. Again, I repeat, the property of a matter to flow is called as fluidity. Fluidity is the tendency, is the property, is the characteristic of a matter to flow, and the matter which flow is called as fluid. Both the terms are different. Fluids are the matter which have the ability to flow, and fluidity is the tendency, the property, or the characteristics of a matter to flow. So, liquids have the ability to flow, therefore, they does not maintain the shape. That means they are not rigid. Liquids have the property of diffusion. Diffusion is the intermixing of the particles of matter, and we have studied that the intermolecular space between the particles of liquid is more as comparative to solid. The intermolecular space between the particles of liquid is more as comparative to solid. That means the other state like solid or liquid or gas, they can easily occupy the space present between the particles of liquid. This side, this side, this side, this side, this side, and this side. Since the space is free, so other particles of other matters, can occupy the space present between the particles of liquid. So we can say that the particles of matters are intermixing, they are mixing with each other. So the liquids have the ability to get diffused, or the liquid shows diffusion. Due to the property of diffusion, the aquatic animals, I repeat, due to the property of due to the property of diffusion, the aquatic animals due to the property of diffusion, the aquatic animals are able to survive, are able to respire, because the aquatic animals need oxygen and the aquatic plants need carbon dioxide, and these oxygen and carbon dioxide are available to the aquatic animals and plants through the property of diffusion. The gases present in the atmosphere get diffused in the water bodies, in the water of the water bodies, and in that form they are present in the diffused state. So we can say that the oxygen in the water is the diffused oxygen, the carbon dioxide in the water is diffused carbon dioxide. Diffused. Okay. Again, as comparing we know that liquids have the property of diffusion. Therefore, the solids, the liquids, and the gases can diffuse into the liquid state. I repeat, since the liquids have the intermolecular space, the solids, the liquids, and the gases can diffuse in the liquid states easily. And the last property is the comparison of rate of diffusion of liquids and solids. Since we know the intermolecular space in liquid is more than solids, therefore the rate of diffusion in liquid will be greater than that of solid. because solid does not have any intermolecular space. So, the particles of liquid will get easily diffused. And the last property is that liquids are compressible in nature. Compressibility means if we apply the pressure, all the particles will come close to each other. Therefore, liquid is compressible as comparative to solid. Solids are incompressible. Moving to the new topic, that is the gaseous state. Again, comparing the property or studying the property of gaseous state have intermolecular force equals to 0. That means there is no intermolecular force present between the particles of gases, or if the intermolecular force of attraction is present, it is equals to or close to 0. Therefore, we can say that the intermolecular space in the gaseous state is very, very high. For example, if one particle is present here, the other particle will be here, the third one will be here, and the fourth one will be here. So we can say that these are the intermolecular space, and all these particles are very loosely held. So particles are away from each other. Thus we can say that the intermolecular space is very high and intermolecular force is negligible in the gaseous state. As we know, gas have no fixed shape and no fixed volume. Volume is not fixed and the shape is also not fixed. And since the gas particles have high intermolecular space, since the gaseous molecules have high intermolecular space, they can easily be compressed. Compressibility means compressibility means if we are taking the gas in a container. So as you can see on the screen, the gaseous particles are away from each other, and if we applied the pressure using a piston, if we move the piston inside, so in the next diagram you can see all the gas particles are close to each other. This is the compressibility. Since they are having higher intermolecular space, so they can be easily compressed. Due to the compressible nature, we use many types of gases. I will give you two types of example that you are very familiar to that. The one is LPG gas, that is called as the liquefied petroleum gas, which is used for the cooking purpose, which is used as a fuel in household work. So LPG gas is used in the cooking as a fuel in the houses. It is filled in the container in the form of liquid state. It is filled in the gaseous cylinder in the form of liquid state. Similarly, you are also familiar of the compressed natural gas, that is called as CNG. CNG is used as a fuel in the vehicles, and it is also called as the cleaner fuel because it is pollution free fuel. So compressed natural gas, CNG, LPG, these gases are filled in the container in the form of liquid due to the compressible nature. In the diagram, you can see that if we compress the particles of the gases, all the particles will come close to each other. That means they will get converted from gas to liquid, because in gases the particles are away from each other in this manner, and if we apply the pressure to the to the particles will come close to each other. That means it will change its state from gas to liquid. So, due to the compressible nature, the gases can be converted into liquid, and taking the advantages of this property, we can use the LPG gas in the liquid state to fill the cylinder, and we can fill the compressed natural gas in the liquid state in the cylinder. And the next property is that the rate of diffusion the rate of diffusion is higher in gases as comparative to solids and liquid, because gas have highest intermolecular space, and we know the diffusion is the intermixing of the particles. The next property is the next property is based on the diffusion nature of gases. Since the gases have high rate of diffusion, the gas particles can easily flow from one place to another as comparative to liquids and solids. I repeat, since the gaseous particles have the property of diffusion, they have the high rate of diffusion, the gaseous particles move from one place to another easily as comparative to liquids and solids. Due to this property, we are able to smell the food which is being cooked in a kitchen within a second. So, smell of hot food is observed very easily as comparative to smell of cold food. The reason behind that is that the reason behind the movement of particles is that the particles of the matter moves with the help of energy, and the energy which is required for the movement of particles is called as kinetic energy. I repeat i repeat the energy which is required for the movements of particles is called as kinetic energy. Kinetic energy is the type of energy which is helpful, which is used in the motion of particles, and the kinetic energy depends on temperature. The kinetic energy depends on temperature. If the temperature is high, the kinetic energy will be high. Kinetic energy will be high when the temperature is high. If the kinetic energy is low, that means the food is cold. That means the food is cold. Temperature is low. I hope you all got it. When the temperature is high, that means the nature of food is hot. The kinetic energy will be high. That means the particles will move very easily, very rapidly from one place to another, and we will get the smell of the food. But if the temperature is low, that means the food is cold. Therefore, the kinetic energy will also be low. If the kinetic energy is less, then the smell of food will not be observed so easily as in the case of the hot food. So, we can say that the kinetic energy depends on temperature. If the temperature is high, kinetic energy will be high and the motion will also be high. Lastly, the gases have the property to exert pressure, to apply pressure on the surface of the wall of the container in which they are filled. The pressure is the force per unit area. Pressure, again I repeat, pressure is the force applied on per unit area of the substance. And Gases have the property to apply pressure on the surface of the container in which they are filled. The reason behind applying the pressure is that the gaseous particles are free to move in all the directions. If the gaseous particles are moving in all the directions, they are hitting each other as well as they are hitting the wall of the container. The hitting means they are applying the force, and force applied on the particular area is the pressure. For example, the balloon. You have seen the balloon. When gas is filled in the balloon, it enlarges in its size. This is because the gas start exerting the pressure on the surface of the balloon, inside surface of the balloon, and due to that pressure the balloon get enlarged. So gases have the property to exert pressure on the surface of the container in which they are kept.